In our last video tutorial, we discussed what are Pythagorean triples. If you haven't watched that video tutorial, then please watch that so that you can understand whatever we are going to discuss here. Its video link is given in the description box below. Now let's begin our discussion. We have a problem here. Find a Pythagorean triple in which one member is 12. We know that we can tell Pythagorean triples using these three algebraic expressions, that is 2m, m squared minus 1 and m squared plus 1. If you put different values of m that are greater than 1, all the positive integers that are greater than 1, if you go on putting here, then you'll get different Pythagorean triples. For 2 it will be something else, for 3 it will be something else, so on and so forth. But here it has been given to us that 12 is one of the member of this Pythagorean triple. So let's say that this is x, this is y, this is z. We don't know whether this 12 is x or y or z, right? No worries. Let's assume first assumption that 12 is actually z. It means that m squared plus 1 is equal to 12. Solve it, you get m squared is equal to 11. Okay. If you put m is equal to 3, then you get 9. No, it is not equal to 11. If you put m equal to 4, you get 16. 4 squared means 16. No, again you're not getting 11. It means that if you try to find out the value of m from here, that will not be an integer value. That will not be an integer value. Okay, that will not be an integer, because if you put m is equal to 3, it's giving you 9, and when you put m is equal to 4, it's giving 16. So between 3 and 4 there is no other integer that can satisfy this one. That's why this assumption is wrong. Let's take next assumption that let this 12 is actually y. It means that m squared minus 1 should be equal to 12. From here you get m squared is equal to 13. Okay, now if you put m is equal to 3, you get 9, because 3 squared is 9. You put 4, m is equal to 4, you get again 16. That is not equal to 13. It means again, if you are trying with this assumption, you'll not get the value of m as integer value. It will not be an integer value. Okay, it means even this assumption is wrong. So let's move to the third assumption, that let this 12 is actually x. Let's assume that. It means 2m is equal to 12. Okay. Now from here you get m is equal to 6. If you divide both the LHS and the RHS by 2, you get m is equal to 6. And from here we have got the value of m. That is m is equal to 6. Now simply put it here. So when you put 6 here, you get 12. This 6 here, 36. 6 squared means 36. 36 minus 1 is 35. 6 you will put here. 6 squared means 36 plus 1 is 37. So this is our Pythagorean triple, right? Another one, it is 18. So again 2m, m squared minus 1, m squared plus 1, right? M should be greater than 1 and it should be positive integer. Okay, let's say that this is x, this is y, this is z. Now one of the member is 18. We don't know whether 18 is x or y or z. Okay, let's assume that 18 is actually m squared plus 1, that is z. So m squared plus 1 is equal to 18. Okay, So m squared gives you what? 17, right? Now, when you put m is equal to 4, 4 squared is 16. No, it is not equal to 17. When you put m is equal to 5, you get m squared as 25. No, it is not equal to 17. It means this assumption is wrong. Next assumption will be that let 18 is equal to y. Let's assume this. It means m squared minus 1 is equal to 18. So from here you get m squared is equal to 90. I missed one point here, that if you solve for this one, m will not be an integer value. You have to write this thing. You have to explain each and everything. And why, if you will say that, okay, if it's not an integer value, what if we are getting a decimal value? No, m should be positive integer that should be greater than 1. You cannot take a decimal value. Okay, so m squared is equal to 19. When you put m is equal to 4, you get 16, not equal to 19. When you put m is equal to 5, you get 25, not equal to 19. It means that again this assumption is wrong, because again here you not get the value of m as an integer value. Okay, so last assumption, that 18 is actually x, that is 2m is equal to 18. If you solve it, if you divide both the LHS and the RHS by 2, you get m is equal to 9, right? Here we are getting an integer value. Okay, so the value of m is equal to 9. Now put this 9 here. So 2 times m9 is 18. Then m squared means 9 squared 81 minus 1 is 80. 9 squared means 81 plus 1 is 82. So this is the Pythagorean triple in this case, where 18 is actually 2m. Okay, this is the last one. One of the member is 35. Again, you have to remember this: 2m, m squared minus 1 and m squared plus 1. M can only be a positive integer and should be greater than 1. Okay, so let's say that this is x, this is y, this is z. We don't know whether 35 is x or y or z. Let's begin our assumption, and let's assume that this 35 is actually z, that is m squared plus 1 is equal to 35, right? From here you get m squared is equal to 34. Now if you put m is equal to 5 here, you get 25, not equal to 34. If you put m is equal to 6 squared means 36, again not equal to 34. So if you solve for this one, if you solve for the value of m, the value of m will not be an integer value. And we'll discuss more on this in coming video tutorial, that what happens when you are not actually getting the value of any variable, whether it is m or x or y. It's not integer, but what happens when you get decimal value and how to calculate that. We'll discuss these things in our future video tutorials. Okay, so again, not integer value, so you cannot take this one, because m has to be positive integer and should be greater than 1. Okay, so this assumption is wrong. The next assumption is that 35 is actually y, that is m squared minus 1 should be equal to 35. And if you solve from here, you get m squared is equal to 36. Now you put m is equal to 6 and you get 36. Yes, it's getting satisfied. This condition is true. From here it means that you get m is equal to 6. Now some of you will say that, hey, you know what, we can even take m is equal to minus 6, because minus 6 squared is actually 36. Yes, but the condition is this one. It should be a positive integer and should be greater than 1. Neither it's a positive integer, neither it's greater than 1. Okay, nor it's greater than 1. So m is equal to 6. Okay, this condition gets satisfied in this one. But let's check for this one also, right? It's good to check for this one. So 2m is equal to 35. Again, if you divide both the LHS and the RHS from here, you get by 2, you get 35 by 2. Of course, this is not a, if you solve for this one, you'll not get an integer value for m. This means that this assumption is wrong. Which assumption is correct? This one. That is m is equal to 6. Now if you put this value of m here, you get 12. Then 6 squared is 36 minus 1 is 35. And 6 squared is 36 plus 1 is 37. So this is a Pythagorean triple for this one, where this 35 is actually m squared minus 1.